Okay, we have Systems Review 1A. So find / how many intersections. So let's identify the intersection and put a dot there and call the point on the x -2, on the y 0. Okay, so how many intersections? That is the intersection. There is one intersection. We can write one int. So one intersection. So if the slopes aren't the same, if the slope m of one is not equal to the slope of another, we're always going to have one intersection no matter what. By geometry, if two lines do not have the same slope in a two-dimensional plane, at some point they will always intersect. Okay, B. So these two lines are parallel, represented by m is equal to m parallel. So these two vertical lines represent parallel. So find the intersection. These lines never touch. How many intersections? We have 0 intersections. So parallel lines never touch. They continue on forever side by side and never actually touch. Okay, 1C. So these lines are on top of each other. They have the same slope, m equals m, and notice they are parallel to each other by definition. But they also have the same y-intercept. So we say an infinite number of intersections. These lines are on top of each other. They have an infinite number of intersections. Find the intersection. Well, every single point on both lines is an intersection. This is an intersection, this is an intersection, this is an intersection, etc. We could list an infinite number of points, but we have an infinite number of intersections. So again, from 1A, if we have different slopes, we always have an intersection, and we're going to find those intersections. If we have parallel lines, they never touch, and we have 0 intersections. If we have two lines on top of each other, we have an infinite number of intersections when we have the same slope and the same y-intercept, whereby they are the same equation. Okay, we have 2A. So they've asked us, is this point 2, 3 are the following points on both lines? So is it on one line, is it on both lines? Notice those questions with all those slashes. You know what you're looking for. Is the point on the line or not? What else can they ask you? Is the point on the line? Is the point on the other line? If it's on both lines, it's the intersection. If it's not, it's not. Okay, so we have the point that, and we have the equation y equals x plus 1, and we have the equation y equals -2x plus 4. Okay, so I'm going to identify the point in red, x, y, to remind me that I'm substituting for x and y. So in the first equation, y is 3. We can substitute 3 for y. And x is 2. We can substitute 2 for x. Plus 1, we know 3 is equal to 3. Therefore, check mark. That point is on this line. Okay. Let's do that again. So we're going to take the point 2, 3 and substitute into the equation on the right. So y is 3, so 3 equals, we have -2. Now this time I'm going to substitute with brackets because it's necessary. If you have any difficulty, always substitute with brackets. I'm going to put brackets on the left in red to show you that sometimes they don't matter. Okay, so substituting 2 in for x, then plus 4 on the left-hand side. We have 3 on the right-hand side. We have -2. Times 2, which is -4, plus 4, which is 3 equals -4 plus 4 is 0, not equal to, not equal to, not equal to, therefore, not on line. Now, if it's on one line and it's not on the other, then it's therefore not the intersection. Now, You can write lazy stuff like int, not int, but I mean technically you should be defining it as intersection at least somewhere. Notice in the last question, intersection. But usually your teachers will let you use those short forms. If they ask you, is the point on the line, is it an intersection? Well, then saying not int should usually be fine. So we could check our answer. Let's check our answer. So if we draw a graph, our first equation has a y-intercept, y equals x plus 1, has a y-intercept of 1, and a slope of 1, up 1 over 1. And we can draw that line. And we can clearly see that the point 2, 3 is on the line. Okay, the other equation I'm going to do in red. So we have a y-intercept of 4, 1, 2, 3, 4, and a slope of -2, down 2 over 1. I'm going to circle this point, down 2 over 1. Draw a line through it. So I'm going to label my equations. This first equation was y equals x plus 1, and the second equation in red is y equals -2x plus 4. So the question was, is 2, 3 on the line? Is it on the line? Is it on both lines? Well, it was on the first line, but it was not on the second line. Therefore, not the intersection. As you can clearly see, the point 2, 3 is not the intersection of the lines. Soon we will solve for the actual intersection of these two lines at 1, 2, but those are for following questions. Okay, let's do that again. Okay, 2a. So we have the point -2, 1, and we have the equation y minus x equals 3, and we have the equation y plus 5 plus 3x equals 0. Now notice in the last question, the equations were in y equals mx plus b form, and we could graph them using the slope and the y-intercept. These are not. Do we want to turn them into y equals mx plus b? We could, but it would be unnecessary. So I'm going to take the point and identify it as x, y. Then I'm going to carefully take that point and substitute it into both equations. So the first equation on the left-hand side, we have y being 1. I'm going to substitute with brackets. Then we have a minus sign. Now we have x being -2. I'm going to substitute with brackets equals 3. On the left-hand side, we have 1 minus -2, which is 1 plus 2. On the right-hand side, we have 3. Notice I don't go back and forth. We're not doing algebra. 1 plus 2 is 3. 3 equals 3. Therefore, we know this point is on the line. Okay, let's do that again with the equation on the right with the same point. So we have a y value of 1. So we're going to take 1 and substitute in for y. Plus 5 plus 3. X is -2. -2 equals 0. So we have 1 plus 5 is 6. Positive 3 times -2 is -6. And the right-hand side says 0. 6 minus 6 is 0. 0 equals 0. Forgot to put a check mark on the last one. Check mark on line. Now, if this equation is on both of the lines, it must be the intersection. Int. Check mark. And again, feel free to write out intersection check mark. Okay, so these equations aren't in y equals mx plus b. We could turn them into y equals mx plus b. So let's take y minus x equals 3 and y plus 5 plus 3x equals 0. So in the equation on the left, if I add x to both sides and leave it in y equals mx plus b form, it will be x plus 3. And in the equation on the right, if I minus 5 and minus 3x from both sides, and put it in y equals mx plus b form, -3x minus 5. Okay, so now let's find out that this point is the intersection of these two lines. So let's first of all draw a graph. Now the equation on the left is a lot simpler. I just have a y-intercept of 3 and a slope of up 1 over 1. Now the equation on the right has a y-intercept of negative 5. So I'm going to extend this graph down, y-intercept of negative 5, and we have a slope of negative 3. Up 3 over 1 in the negative direction. Up 3 over 1 in the negative direction, which means this is the intersection. Up 3 over 1 in the negative direction. Put a line through it, and we can clearly see that our intersection is negative 2 comma 1, verifying that it was the intersection and that we have done it correctly. So remember, again, in the last one, if it's on one line but it's not on the other, it's not the intersection. If it's not on both lines, it's obviously not the intersection. It must be on both lines to be the intersection. And we can solve for it algebraically by checking to see if the point is on the line, and then we can graph it and actually find out if it's on the line. In the next few questions, we're going to be actually solving algebraically for the intersection point, where this question, they give you a point and ask you if it is the intersection or not. Remember, it must be on both lines to be the intersection. Okay, we have 2C. We have the point 2 comma 1, and we have the equation 3x plus 2y equals 6, and we have the equation x minus 3 equals y. So is this point on the line, and is it the intersection of both lines? So we have x comma y, and we can substitute. We have 3 times the x value of 2 plus 2 times the y value of 1 equals, the right hand side says 6. On the left hand side we have 3 times 2 is 6, 2 times 1 is 2, 6 plus 2 is 8. The right hand side says 6. Not equal to each other. Not on line. Okay, this next equation, we have x minus 3, so we have an x value of 2. Substitute that in. A y value of 1. 2 minus 3 is negative 1. Negative 1, the right hand side says 1. Not equal to each other. Not on line. Therefore, not the intersection. So, obviously, if it's not on both lines, it's just not the intersection. Okay, so let's graph these just to prove that. So let's take 3x plus 2y equals 6, and let's mirror the other equation, y equals x minus 3. So for this equation on the left, I'm going to do a table of values and choose x and y, so I don't have to convert it into y equals mx plus b sometimes. So I'm going to choose values of x of 0 and substitute. So we get 3 times 0 plus 2y equals 6. 3 times 0 is 0. Divide both sides by 2, and we get y equals 3. Then we'll put 0 in the y column, and we'll substitute 0 in for y. So taking the equation again, and putting 0 in for y. 2 times 0 is 0. Divide both sides by 3. X equals 2. Put that in the table. Forgot to circle my partial answers. And then we can draw that. So let's draw this graph over here where we have some space. So we have a point of 0, 3. We have a point of 2, 0. And we can draw a line through it. Down 3 over 2, down 3 over 2. Okay, and then the other equation, y equals x minus 3, that's already in y equals mx plus b form after we've mirrored it. So we have a y-intercept of negative 3, and we have a slope of 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, etc. Whoops, missed that last point. And we can clearly see that the point 2, 1 is not on both lines, and obviously, therefore, not the intersection. So, in review, we have question number 2A, where it was on one line, so obviously not on the intersection, and it doesn't matter that it's not on the other line. In 2B, it was on both lines, and therefore the intersection. If it's not on both lines, it's just not the intersection, obviously, in 2C. So those are going to be the three types of idiosyncrasies that you can see with respect to points being on the line, on the other line, or not, and whether or not is the intersection, therefore. Okay, we have 3A. So the question says, find the number of solutions or the number of intersections. So we have the equation y equals 2x minus 3, and we have the equation y equals x plus 4. So right away we know that m is not equal to m. They have different slopes, different coefficients of x. Therefore, one intersection, as we saw from question number 1. If we have different slopes, we have one intersection. Okay, B, y equals 3x minus 8. Again, y equals 3x plus 2. So this time we have the same slope, but different y-intercepts, therefore 0 intersections. Again, remember from question number 1, if we have the same slope, but different y-intercepts, these lines are parallel, and we have no 0 intersections. Okay, C, we have y equals x plus 1, and we have y equals x plus 1. Well, these are the same line, the slope is the same, and they have the same y-intercept. Therefore, these lines are the same line, they're on top of each other, and we have infinite intersections. Okay, D. So let's take 2x minus y minus 3 equals 0. And let's take x minus y plus 4 equals 0. Now, we need to get these into y equals mx plus b so we can more clearly see what the slope and the y-intercept are, so we can avoid using more complex formulas. So in the equation on the left, I'm going to add y to both sides. Then I'm going to say 2x minus 3 equals y. Then I'm going to mirror it. Y equals 2x minus 3. In the equation on the right, I'm going to subtract x and subtract 4 from both sides. And I get negative y equals negative x minus 4. Then I'm going to divide both sides by negative 1 over negative 1 over negative 1 over negative 1, not doing the lazy thing. Therefore, y equals a negative divided by a negative is a positive. And notice we have different slopes. Therefore, we must have one intersection. Okay, we have E, A, B, C, D, E, 6x minus 2y equals 16, and 6x minus 2y plus 4 equals 0. So, in the first equation, instead of doing algebra, I'm going to use the term bring it over. I'm going to bring this over here and this over here. Now remember, we're actually doing algebra. So when I add 2y to both sides, I end up with 2y on this side. When I subtract 16 from both sides, I end up with 16 on this side. So just a nice little trick to learn how to do algebra quicker. Your teachers are going to start skipping steps, and we have to start learning some of these shortcuts so we can follow them in class. Also, it will be much easier for you to see quicker solutions in the future. So we have this 2 in front, so we're going to divide both sides by 2. And I'm going to mirror it at the same time. 2y divided by 2 is y. Y equals, notice I put the right-hand side on the left-hand side, mirroring, not bringing it over. You know what? That's too much. I'm going to do it first. 6 divided by 2 is 3, 3x. 8, 16 divided by 2 is negative 8. And 2 divided by 2 is y. And then you could mirror it if you wanted to. I was going to, but we're good there. So we're going to do the same thing. We're going to bring the negative 2y over to that side by adding 2y to both sides. So we're going to have 6x plus 4 equals 2y. Then we're going to divide both sides by 2. And we get 3x plus 2 equals y. Again, it's in y equals mx plus b form, but it's mirrored. So we have the same slope and different y-intercepts. Therefore, these lines are parallel, and we have 0 intersections. Okay, so ABC, that's all the different types. We can have 1 intersection, 0 intersections if they're parallel, infinite intersections if you solve them to be the same line. And those are the 3 different cases we're going to have. Okay, we have 4a. So, solve by substitution and graphing and check your solutions. So we have y equals x plus 1, and we have y equals negative 2x plus 4. Notice it's in brackets. Does that matter? No. Okay, so solve by substitution. So if I know y equals this and y equals that, I know that this and that are equal to each other. So we can substitute. So then we can solve the equation. So we can add 2x to both sides. Then we can subtract 1 from both sides. Then we can divide both sides by 3, and we get x equals 1. Circle your answer. Now, we can take either of the 2 equations. Let's take the easier one, y equals x plus 1. And we can take 1, substitute for x, and find y. Y equals the 1 that we just figured out. Y equals 2. Circle your answer. Immediately write your intersection 1, 2. This question probably feels familiar. So now let's graph it. So let's take the point, the graph, x plus 1, y-intercept of 1, and a slope of 1. And the other equation has a y-intercept of 4 and a slope of negative 2. Circle the intersection, down 2 over 1, down 2 over 1, put a line through it, and call it the intersection 1, 2, and confirm that you are correct. Then it says check your solution. So then take your equation, y equals x plus 1, and substitute x and y. So the solution that we got is 1, 2. We have a y value of 2 and an x value of 1. And 2 equals 1 plus 1 is 2. Absolutely. So if you remember in question number 2, they asked, is the point an intersection? And you just put it in. Well, now they give you the equations, you find the intersection, and then confirm that it is. It's actually not necessary to confirm that it is, nor graph it. You can just do the algebra to find the intersection. But now let's try the other equation. And let's substitute for x and y. So again, we have a y value of 2 and an x value of 1. So we get 2 equals negative 2 times 1 is negative 2 plus 4. 2 equals 2, check mark. We absolutely know that 1, 2 is the intersection between these 2 lines. And we did it by substitution, graphing and checking your answer. Okay, we have 4b. So we have the equation x equals 3 minus y, and we have the equation 2y minus 2x equals 10. Okay, so we know what x is equal to. Let's put brackets around what x is equal to, and let's put brackets around x in the other equation. Now let's carefully take what x is equal to and substitute it into the other equation. We have 2y minus 2 times 3 minus y from the other equation equals 10. Then we can distribute the negative, so negative 2 times 3 is going to be negative 6, and a negative times a negative is going to be a positive, and 2 times y is 2y equals 10. Okay, we have 2y plus 2y, which is 4y minus 6 equals 10, and let's add 6 to both sides, and we'll get 4y equals 16, and divide both sides by 4, and y equals 4. Circle your answer. Then we can take y and put it into the other equation. Let's skip a few lines so we know what we did first. X equals 3 minus our y value of 4, and we're going to get x equals 3 minus 4 is negative 1. Circle your answer. Immediately write down your intersection point, negative 1 comma 4. Circle your answer. So that is the intersection between these two lines. So the equation on the left, x equals 3 minus y, we can simply add y to both sides. X plus y equals 3, and subtract x from both sides. And put it in y equals mx plus b form, negative x plus 3. We can then turn the other equation into y equals mx plus b form. We have 2y minus 2x equals 10. We can add 2x to both sides or bring it over. 2y equals, if we add 2x to both sides, it will say 2x plus 10. Then if we divide both sides by 2, we'll get y equals x plus 5. So those are the two equations in y equals mx plus b form. We can then graph them both. So we have a graph. So first of all, we have a graph with a y-intercept of 3 and a slope of negative 1, up 1 over 1, up 1 over 1 in the negative direction. Then we have the equation on the right, y equals x plus 5. We have a y-intercept of 5 and a slope of up 1 over 1. And we have the intersection of exactly negative 1 comma 4. Confirming our intersection is correct with graphing. Now let's check our answer by substitution, like in question 2. So you can take any equation that you like. Now, because we may have it's highly unlikely, but we may have incorrectly isolated for y, let's take the original equations. X equals 3 minus y, and 2y minus 2x equals 10. So let's take the intersection, negative 1, 4, and substitute for x and y. So we have an x of negative 1 and a y of 4. Negative 1 equals 3 minus 4 is negative 1, check mark. So again, the equation on the right, taking the same point, we have a y value of 4. We have an x value of negative 1. On the left-hand side, we have 2 times 4 is 8. Negative 2 times negative 1 is positive 2 equals 10. And 8 plus 2 is 10. 10 equals 10. Check mark. So, solving by substitution, finding out what the intersection is, then graphing it either with the table of values like we did in a couple of the last questions, or turning it into y equals mx plus b, finding the intersection, then confirming that your intersection is absolutely correct by checking your answer to see if it is the intersection, checking it the third time over. Okay, what do we have here? We have 4C. So we have 2y equals 2x minus 6, and y equals x minus 3. So, first of all, we can clearly see that y equals x minus 3. We can take x minus 3 and substitute into y in the equation on the left. So we'll have 2 open bracket, x minus 3 equals 2x minus 6. Then we can distribute. So we get 2x minus 6 equals 2x minus 6. So we can minus 2x from both sides. And we can clearly see that negative 6 equals negative 6. Now, you could add 6 to both sides and get 0 equals 0. But either one of these lines will be fine to tell us that a number is equal to a number. That means that they're the same line, and we have an infinite number of intersections. So if we take the equation on the left, 2y equals 2x minus 6, and divide both sides by 2, we'll get y equals x minus 3. We can clearly see that the other equation is exactly that. And we could draw the graph. We have a y-intercept of negative 3, a slope of up 1 over 1, and draw a line through it. And the other equation has the same y-intercept and the same slope. So these lines are on top of each other. These lines are parallel. They are the same line, and we have an infinite number of intersections. If we want to test our point and take our equation, y equals x minus 3, and substitute the x and the y value in, well, pick any value on this line that you want. For example, 3, 0, and substitute. We have a y value of 0, x value of 3. 3 minus 3 is 0. Check mark. Infinite number of solutions. So be very careful with that case. If you get a number equals a number, it's infinite intersections. So in the last two questions, we saw one intersection for each because they had different slopes. This question, they were exactly the same line. Therefore, we have an infinite number of intersections. Okay, 4D. So we have 1/2 x plus 1 equals y, and we have 2y plus x equals 4. Okay, so I can clearly see that y is equal to something, so I can put brackets around what y is equal to. I can put brackets around y in the other equation. I can carefully substitute. So we have 2 times 1/2 x plus 1 plus x equals 4. We can distribute. 2 times 1/2 is 1, so we have 1x. And 2 times 1 is positive 2, plus x equals 4. So we get x plus x is 2x, plus 2 equals 4. We can subtract 2 from both sides. 2x equals 2. Divide both sides by 2. X equals 1. Okay, then we can take 1 and put it into the other equation. So skipping a couple lines, 1 over 2 times 1 plus 1 equals y. 1/2 times 1 is 1/2 plus 1 equals y. I can add fractions. So that'll be 1 over 2 plus 1. 1's over 1. We have to times the top and bottom by 2 equals y. Therefore, we get 1 over 2 plus 2 over 2 equals y. Therefore, we get 3 over 2 equals y. Circle our answer and immediately write down the intersection, 1, 3 over 2, or 1.5. So, the equation on the left, 1/2 x plus 1 equals y, is in y equals mx plus b form. We can draw that graph. We can put a y-intercept of 1 and a slope of up 1 over 2, up 1 over 2, and draw that line. Then we can take the other equation, 2y plus x equals 4. We can subtract, I won't do that type of stuff in here. Sorry about that. We can subtract x from both sides, minus x minus x. Therefore, 2y will equal negative x plus 4, divide both sides by 2, and we get y equals negative 1/2 x plus 2. And that's a y-intercept of 2 and a slope of down 1 over 2, down 1 over 2. And we can clearly see that we have an intersection point at 1, 3 over 2, or 1.5, confirming that our answer is correct from above. Now, again, check your answer by taking the values and substituting them. So we're running out of space here a little bit, so I'm going to do some work in this left area over here, right area over here. So let's take the equation 1/2 x plus 1 equals y, and let's take the intersection point that we just figured out and substitute. So we get 1 over 2 times an x value of 1 plus 1 equals 3 over 2. And 1/2 times 1 is 1 over 2 plus 1 is 3 over 2. And we just showed you adding fractions. We know 3 over 2 equals 3 over 2. Check mark. So let's take the other equation. I'm going to do it in red. In red, 2y plus x equals 4. Taking the y value, 2, and substituting the y value of 3 over 2. Plus the x value of 1 equals 4. 2 times 3 over 2, we can cancel the 2's, and we're left with 3 plus 1. And 3 plus 1 is also 4. Check mark, checking our answer by putting the value back into both equations and finding out if we did our algebra correctly and if we graphed it correctly. Okay, we have 4e. That's an e. So we have the equation y equals 2x plus 5 and the equation y equals 2x plus 1. Now, you can clearly see that we have the same slope and different y-intercepts. We know that these lines are parallel and we have 0 intersections. But let's prove that. So we have y equals 2x plus 5 and y equals 2x plus 1. We can take those equations and make them equal to each other. We can subtract 2x from both sides. And then 5 equals 1. 5 is not equal to 1. Not equal to. Therefore, if we get number not equal to number, we have 0 intersections. These lines are parallel. Remember, from the 2 questions ago, we got number equals number, which was an infinite number of solutions, infinite number of intersections. Whereas if we have different slopes, then we just have 1 intersection. So these are just the idiosyncrasies of the algebra, just in case you get some odd answers. That is what it is. We could obviously graph these 2 equations. We have a y-intercept of 5 and a slope of 2 in both directions. And we have a y-intercept of 1 and a slope of 2 in both directions. And we can clearly see that these lines are parallel. They never touch. They have 0 intersections. So when we get number not equal to number, 0 intersections. Again, when we get number equals number, that's an infinite number of intersections. Whereas the other equations, we just actually got answers, which were the intersections. So be very careful with those, and very interesting algebra and solutions sometimes. Okay, we have 5a. 2y equals x minus 2, and we have y equals x minus 3. Solve by elimination and graphing and check solution. So remember, I'm checking by graphing. You don't have to check by graphing. You just have to find the intersection and check your answer. I'm just showing you that it's an extra step that you can do sometimes. Maybe I won't do it every time because it got a little bit repetitive in the last question. So we want to eliminate something. So first of all, is 2y minus y 0? No. Is x minus x 0? Yes. We are ready to take one of the equations and put it on top or below the other. Y equals x minus 3. Now, x minus x is 0. Therefore, we know we want to subtract the equations, and we want to put brackets around the equation on the bottom to be careful. 2y minus y is simply y. Y equals x minus x is 0. That's gone. Now we're doing negative 2 minus negative 3, which is negative 2 plus 3, which is equal to 1. Y equals 1. Circle your answer. Take the easier of the two equations. Y equals x minus 1. Substitute the y value back in. 1 equals x minus 1. Add 2 to both sides. Mirror it. X equals 3. Circle your answer. Immediately write down the intersection. 3, 1. Circle your answer. So elimination is going to be a lot easier in a lot of these cases. Some of these questions, it's just so much easier just to eliminate a variable because it's way less algebra. But you learn substitution first, so for some reason you think it's a simpler thing to do. So we can check by graphing. So the first equation, we have 2y equals x minus 2. We can divide both sides by 2. Y equals, we have a slope of 1/2. Negative 2 divided by 2 is negative 1. And then we have the equation y equals x minus 3. So we can take these equations and we can graph them. So we have a y-intercept of negative 1 and a slope of up 1 over 2, up 1 over 2. Then, excuse me, y-intercept of, okay, then we have a y-intercept of negative 3, and it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Whoa, up 1 over 1, up 1 over 1. So, I'm going to go back to the original line with my y-intercept of negative 1 and do up 1 over 2, up 1 over 2, up 1 over 2 one more time. I'll put a line through it. Then, I'm going to draw a line through my other line. Now, what have I just realized? Well, look at my intersection. What is that intersection value? It is 1, 2, 3, 4, 1. What did I do wrong here? Oh, I incorrectly copied the question down wrong. Let's try that again. Y equals x minus 3. Look how easy it is just to make a simple mistake, incorrectly copying the question down and substituting. So now, if I take that y value that we got earlier and we substitute it, we're going to get the y value of 1 equals x minus 3. When we add 3 to both sides and mirror it, x equals 4. Therefore, our new intersection is 4, or our only intersection that should have only ever been is 4, 1, not 3, 1. So important to check your answer by graphing. It's so simple to do, such an easy step to make sure that you did it correctly, just in case you might have done some sort of an algebraic error. Okay, so let's check our answer. So let's take the point, let's take our first equation, 2y equals x minus 2, and let's take the point that we just figured out correctly, 4, 1, and let's substitute for x and y. So we have 2 times 1 equals 4 minus 2. 2 times 1 is 2. 4 minus 2 is 2. Check mark. Okay, let's take the other equation. I'm going to more carefully write it down. X minus 3. And we can take the point and substitute. So we have x is 4, y is 1. So 1 equals 4 minus 3. 4 minus 3 is 1. Check mark. We absolutely know our point 41 is correct. So we have substitution, elimination, graphing, and checking your solution. Okay, we have 5a. So we've got 2y equals x minus 2, and we've got y equals x minus 3. Okay, so first things first, is 2y minus y 0? No. Is x minus x 0? Yes. Are all the terms lined up? Yes, because they're in the form y equals x plus or minus a number, or any version where they're lined up. So we can take one of the equations and put it below the other one. I'm going to take the equation on the right and put it below the equation on the left. It says y equals x minus 3 over, and then we're going to minus. I'm going to put brackets around the equation on the bottom. So 2y minus y is simply y. X minus x is 0. Now, negative 2 minus negative 3 is going to be equal to negative 2 plus 3, which equals 1. So y equals 1, circle your answer. Now let's use the equation on the right because it's a little bit simpler, but it doesn't matter. Y equals x minus 3, and take the y value of 1 that we just got, put it in. 1 equals x minus 3, and add 3 to both sides. Plus 3, mirror it, x equals 4, circle your answer. Immediately write down your intersection, 4, 1. Circle your answer. Okay, so 4, 1, is this the intersection between these two lines? Well, let's find out by graphing. So let's take the equation on the left and divide both sides by 2. Y equals, we have a slope of 1/2. So we can draw that graph. We have a y-intercept of negative 1, and up 1 over 2, up 1 over 2, up 1 over 2. Put a line through it. Then we have the other equation, y equals x minus 3. We have a y-intercept of negative 3, and up 1 over 1, 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 up 1 over 1. And we have found the intersection to be 4, 1, knowing that our point is correct, checking by graphing. Let's also check our answer by substitution. So let's take the point 4, 1 and substitute in for x and y. So first of all, the equation on the left, 2y equals x minus 2. Then we can take the y value of 1, substitute in for y. 2 times 1 equals the x value of 4 minus 2. 2 times 1 is 2. 4 minus 2 is 2. We know it's correct. We know it's on that line. Let's take the other equation, the equation on the right, y equals x minus 3, and take our x and y value. We have a y value of 1 and an x value of 4. 4 minus 3 is 1. Check mark. We know our point 4, 1 is correct by elimination, by graphing, and by checking our answer. So that is how we do the questions by elimination. Notice that in the previous question we did substitution. Valid. You can do any method you like, or unless the teacher tells you to do a specific method, and you decide based on the information. So I'm not going to keep graphing those solutions as we did in all of number 4, A, B, C, D, E, or whichever, by graphing it as well. So we're now just going to continue by elimination, but just get the answer and still check our answer. Okay, we have 5b, y plus x equals 6, and y minus x equals 4. So you can eliminate x or y, and you can add or subtract the equations. In the last question, we eliminated x by subtracting the equations. But this time we have a positive x and a negative x. So this time, notice everything's all lined up, so we can take one of the equations and put it below the other, because x plus negative x is 0. So this time I'm going to put the other equation below this equation, over, brackets around it, but this time I'm going to add the equations together. So y plus y is 2y, negative x plus, or x plus negative x, x plus negative x is x minus x, which equals 0. So those cancel, and we get 6 plus 4 is 10, and divide both sides by 2, and y equals 5. Circle your answer. Take the easier of the two equations, whichever one you like. This time let's take the equation originally on the left. and take the y value of 5 and substitute it into the equation. The y value we just got, minus 5 from both sides, and x equals 1. Circle your answer, and we have an intersection of 1, 5. Circle your answer. So again, feel free to check by graphing, but let's just check by substitution. So if we take both of our equations, y plus x equals 6, and y minus x equals 4, and substitute. So on the left equation, we have y is 5, x is 1, and on the left-hand side, 5 plus 1 is 6, and on the right-hand side, we also have 6. Therefore, we know it's definitely on that line. Then again, we can take the x value, or the 0.1, 5, and take the y value of 5 and substitute it with an x value of 1. Notice you could substitute with brackets if it was necessary. And 5 minus 1 is 4, equals 4. Again, we just checked to make sure that the point was on both lines and therefore the intersection. You don't have to do that. You can give up right after you've done the algebra to find out. It's just a great way to check. Again, you could also check your answer by graphing these things either with the table of values or turn them into y equals mx plus b and graph and find the intersection like we did in so many of the previous questions. Okay, we have 5c. So let's take y equals negative 6x plus 2 and y plus 4x equals 0. So everything's all lined up. In the previous two questions, we added the equations together and we subtracted the equations together to eliminate x. This time, let's eliminate y. So first things first, we need to line up the terms. So I like the terms lined up on the left equation better, so I'm going to minus 4x from both sides on the equation on the right. Y equals negative 4x all by itself. Okay, so because y minus y is 0, we can take one of the equations and put it below the other one. So y equals negative 4x. We can put brackets around the equation and underline. And this time let's eliminate y. Y minus y is 0. This time we have to write it because the term is on the left with nothing else. Negative 6x minus negative 4x. That's a difficult calculation. I'm going to write it off to the right. Negative 6 minus negative 4 is negative 6 plus 4, which is negative 2. So we get negative 2x plus 2. We can minus 2 from both sides. We could have added 2x. Minus 2 equals negative 2x. Divide both sides by negative 2. Mirror it. X equals 1. Circle your answer. Take the easier of the two equations. So they're both fairly similar. I'm going to take the equation on the right just for fun. Y plus 4x equals 0. Take the x value of 1. Y plus 4 times 1 equals 0. Y plus 4 equals 0, minus 4 from both sides. Y equals negative 4. Circle your answer. Immediately write down the intersection. 1, negative 4. Circle your answer. Okay, so we found the intersection between these two lines. Again, we could graph it and find the intersection, but let's check our answer with algebra. So let's first take the equation on the left. Y equals negative 6x plus 2, and substitute x and y. So the point that we just got, 1, negative 4, we have a y value of negative 4, so negative 4 equals negative 6 times our x value of 1 plus 2. On the left-hand side, we have negative 4. On the right-hand side, we have negative 6 times 1 is negative 6 plus 2. And on the left-hand side, we have negative 4, and negative 6 plus 2 is negative 4. Therefore, we know it's on that line. Okay, let's take the equation on the right. Y equals 4x. Y plus 4x equals 0 from above. And taking the y value of negative 4 plus, open bracket, the x value of 1 equals 0. Negative 4 plus 4 times 1 is 4 equals 0. Negative 4 plus 4 is 0. 0 equals 0. Check mark. We know it's on that line. We know it's on both lines. We know it's absolutely the intersection between the two lines by solving by elimination and checking your answer by substitution. So remember, in the previous two questions, we eliminated x by adding and subtracting the equations. We can obviously eliminate either x or y depending on what we like. In this question, we learned that we had to line up the terms. So it was in the form y equals x plus number. And that form doesn't matter. As long as they're both in that same order, then that means they're lined up. So do not try to eliminate unless they are lined up. So lining up the terms, eliminating y, solving for x, substituting, solving for y, and checking our answer. Finding the intersection to be 1, negative 4. Okay, we have 5D. So this time we have the equation 2x minus 3y equals 2. And we have the equation x plus 2y equals 8. So, is 2x minus x plus or minus x 0? No. Is negative 3y plus or minus 2y 0? No. So, we need to take one of the equations and multiply it by a number to allow us to eliminate the terms. So, on the equation on the left, we have 2x. We want to get the same coefficient on the equation on the right, so we're going to have to times the equation by 2. All three terms. So when we distribute that 2 backwards, you're going to get 2x plus 4y equals 16. So notice the terms are all lined up in the form x plus or minus y equals number. As long as they're lined up in the same order, it doesn't always have to be the same order, they just have to be in the same order. So now, if we take that equation on the right and put it below the equation on the left, now that we have the same coefficient of x or y, then because 2x minus 2x is 0, we're going to want to subtract the equations, putting a minus sign to the left of the brackets. 2x minus 2x is 0, that's good. Negative 3 minus 4 is going to be negative 7y. Again, that's a little bit difficult, so I'm going to do it off to the right. Minus 3 minus positive 4 is minus 3 minus 4, which is negative 7. And 2 minus 16 is equal to negative 14. Excuse me. So we can divide both sides by negative 7. And we get y equals positive 2. We can then take the easier of the two equations. It doesn't matter. I'm going to write it down below. And we can take the y value, substitute in for y, and solve for x. 2x minus 3 times our y value we just figured out. 2x, negative 3 times 2 is negative 6. If we add 6 to both sides, we get 2x equals 8. Divide both sides by 2, x equals 4. Immediately your intersection 4, 2, circle your answer. So we found the intersection by elimination, and now we're going to check our answer by substitution. So we have our first equation, 2x minus 3y equals 2. And then let's take the x and the y value and substitute. So we just got the point, 4, 2, so we have an x value of 2, so 2 times 4 minus 3 times 2. The y value, 2 times 4 is 8, 3 times 2 is 6, minus 6 equals 2, 8 minus 6 is 2, 2 equals 2, check mark. 4, 2 is on the first line. Now if we take the other equation, x plus 2y equals 8, and take the values and substitute in for x and y, we have an x value of 4, we have a y value of 2, 2 times 2 is 4, 4 plus 4 equals 8, 8 equals 8, check mark. We know 4, 2 is on both lines, is the intersection between both lines by checking with by solving by elimination and checking your answer. So notice we've done enough checking your answer. We've checked our answer in every single question, a bunch of them with graphing and checking your answer by substitution. Now we're just going to be doing the algebra of elimination because they are more complicated steps and we want to spend more time learning about how to do those complicated steps. So far, the steps we've learned are eliminate x or y through addition or subtraction. Sometimes we have to line up the terms, And sometimes we have to multiply by a value to allow us to eliminate a variable. Okay, we have 5e. So we have 3y plus x equals 4, and we have 0.5y plus x over 3 equals 3. So the equation on the right, I want to call 0.5 1/2 y. If you have any difficulty turning decimals into fractions, go back to grade 8 and learn how to do that. Now I have a 2 on the bottom and I have a 3 on the bottom. I want to times both sides by the lowest common denominator, which is equal to 6. Now, when I multiply the first fraction by 6, I don't actually want to multiply the fraction. I want to think what cancels, what am I left with? I'm going to do that off to the right. So 1 over 2 times 6, well, I have a 6 on the top and a 2 on the bottom, so that's 3 and 1. Cross-canceling or cross-simplification, and 1 times 3 is 3. So we're going to get 3y. Now, if I times the second fraction, x over 3 by 6, 6 divided by 3 is 2, so we're left with positive 2x. Again, feel free to do that off to the right. Keep in mind, x over 3 is just 1x over 3, or 1/3 x, when you're going to be multiplying those fractions. The LCD 6, 3 times 6 is going to be 18. Now, the terms are lined up, and 3y minus 3y is 0, so we're ready to take one of the equations and put it below the other equation. So we can put brackets around the equation on the bottom, we can put an over, and we can minus. 3y minus 3y is 0, that's gone. X minus positive 2x is x minus 2x, which is negative x, which is negative x. And 4 minus 18 will be negative 14. Divide both sides by, negative 1. And we get x equals 14. Circle our answer. Okay, what's y? Well, let's take the easier of the two equations. I like the equation on the left better, so I'm going to start with that one. 3y plus x equals 4. Taking our x value of 14 and substituting it, 3y plus 14 equals 4. Minusing 14 from both sides, 3y equals negative 10. Dividing both sides by 3, y equals negative 10 over 3. Who cares? It's a fraction, whatever. So we have our point, 14 comma negative 10/3. Circle your answer. So in this example, we learned to get rid of the lowest common by the denominators by multiplying both sides by the lowest common denominator, a new method which will allow us to get in a nice simpler form than, because everything was lined up and because 3y minus 3y was 0, we could eliminate the y variable, solve for x, then solve for y, and just notice our point is a decimal. Remember, we're not graphing this solution and we're not checking our answer like we have in all of the previous questions. So, summing up all of our methods that we've learned so far, line up the terms, eliminate a variable x or y by adding or subtracting. Sometimes multiply the equation by something to allow you to eliminate one of the variables, and sometimes do more complicated algebra to eliminate one of the variables by multiplying both sides by the LCD to get rid of the denominators, then possibly multiplying it again, then eliminating that variable. Don't be afraid of decimals and fractions. Okay, we have 5f. So we have 2x plus 7y equals 16. And we have 3x plus 5y equals 13. So, is 2x minus plus or minus 3x 0? No. Is 7y plus or minus 5y 0? No. Can we multiply the equation on the left to get the same coefficient of x as the equation on the right? No. We can't multiply 2 by an integer to get 3. So we have to multiply the equation on the left by 3 and the equation on the right by 2. So if we distribute backwards, we're going to get 2x times 3 is going to be 6x. 7y times 3 is going to be plus 21y. 16 times 3 is going to be 48. Okay, the equation on the right, multiplying it by 2. 3 times 2 is 6x. 5 times 2 is plus 10y equals 13 times 2 is 26. So notice we multiplied both equations by the number that allows us to eliminate the variable. And that 6 was just the LCD between 2 and 3. So that's why we multiplied the equation on the left by 3 and the equation on the right by 2. So now we can take one of the equations and put it below the other equation. We can put brackets around the equation and an underline and minus the equations from each other. 6x minus 6x is 0. 21 minus 10 is 11y. And 48 minus 26 is 22. Divide both sides by 11. Y equals 2. Circle your answer. Take the equation from the right. Before you multiplied it, 3x plus 5y equals 13. And take the y value of 2 and substitute it. 3x plus 5 times 2 equals 13. You could have put it into the equation that you multiplied. It's the same equation. So 3x plus 10 equals 13, minusing 10 from both sides. 3x equals 3. Divide both sides by 3. X equals 1. Circle your answer. Immediately the intersection. So in the last question, we learned to get rid of a fraction by multiplying both sides by the LCD. In this question, we learned that we need to use the lowest common multiple principle to multiply both equations by a number so it will allow us to eliminate a variable, and we used the lowest common multiple principle. Notice I wrote LCD, it should have been LCM, all the same, well, similar. So very tricky questions. Okay, number 6, cell phone plans. Which plan would you choose and why? So we have plan A, we have plan B, and we have plan C. So we want to choose the cell phone that is cheapest. So first things first, in the next few questions, we're going to be doing a bunch of word problems that actually solve for the intersections, just like we learned how to do the algebra in the previous questions to find the intersections. But now we're just going to be answering the questions. So we always want to choose the cheapest plan. So if we use between 0 and 40 gigabytes, we'll want to choose plan A. If we use between 40 and 120 gigabytes, we'll want to use plan B. And if we use over 120 gigabytes, we'll want to use plan C. So we'll want to fully understand how we read these graphs. We always want to make some kind of a decision based on the given information. You're either just looking for an intersection or you're interpreting that intersection and explaining the situation before or after the intersection. So now we're going to take a look at a whole bunch of word problems that find a single intersection between two lines. Notice this is a little bit more complicated with 3. And we're going to find those intersections and interpret what those intersections mean and what below those intersections means and what above those intersections means. Okay, question number 7a. So let's take 7a. So the sum of three numbers is 67. The second number is one less than twice the first. So what's the first? Well, let x equal 1 st hashtag. Now the second number, let, is one less than twice the first. So twice the first is x, 2x, and one less than that is -1 equals the second number. The third number is 4 more than the first. So let x plus 4 equal the third number. Now it says the sum of these three numbers is 67, so we can set that up. X plus 2x minus 1 plus x plus 4. Now it would have been safer to substitute these in with brackets, but those brackets are unnecessary because we don't have any negatives in front. Now that is equal to 67. So clean it up. On the left-hand side, we're going to have x plus 2x plus x is 4x. Then we have -1 plus 4. -1 plus 4 is +3 equals 67. We can minus 3 from both sides. 4x equals 64. Divide both sides by 4. X equals 16. Circle your answer. So answer the question. First number equals 16. Second number equals. So 1 less than twice the first. Well, twice the first, 16 times 2 is 32, and 1 less than that is 31. So the second number is 31, and the third number is simply 4 more than the first. Therefore, 16 plus 4 equals 20. And if we add up all those numbers, we get 67. Therefore, we know we are correct. So keep in mind that's a grade 7, 8, 9 type of question, just to sort of start building us up to be able to solve these more difficult grade 10 questions. So let's do a little bit more review. Okay, 7b. The sum of three consecutive integers is 24. So we're going to let x equal the first number. Then we have a consecutive, three consecutive integers. So consecutive to x will be x plus 1. Let x plus 1 equal our second number. And our third consecutive integer will be let x plus 2 equal our third number. Now it's saying the sum of these numbers is 24, so let's set that up. X plus 1. Again, remember I could have used brackets, but there's no negatives in front. Plus x plus 2 equals 24. On the left-hand side, we have x plus x, which is 3x, and we have 1 plus 2 is 3, so plus 3 equals 24. Minus 3 from both sides, and 3x equals 24 minus 3 is 21, and divide both sides by 3, x equals 7. Circle your answer. Therefore, our first number is 7, and our second number consecutive to 7 would be 8, and our third number consecutive to 8 would be 9. Equals. And these numbers sum to get 24, so we know that we are correct. So notice I didn't actually ask in either of the questions to solve for anything. I just said this information. You just know you have to use the information to solve for something. So you know you have to do something with it. Obviously solve for x. Okay, we have 7c. So it says find two consecutive odd integers. So let x equal the first number. Now, in the last question, it was consecutive integers, so it's x plus 1. But if it's consecutive odd integers, like 5 and 7, we'd have to plus 2. So plus 2 equals the second number. Now it says 5 less than triple the second. So 5 less means minus 5. Triple the second would be 3 times the second. And 5 less would be minus 5. And it says that where 5 less than triple the second is quadruple the first. So equals 4 times the first. Okay, so let's clean that up. Let's distribute. We're going to get 3x plus 6 minus 5 equals 4x. If we minus 3x from both sides, minus 3x from both sides, and 6 minus 5 is 1, 1 equals x. Circle your answer. Therefore, the first number equals 1, and the second number equals 3, being consecutive integers. And if we follow the instructions, tripling the second less 5 should equal 4 times the first. So let's check that. 3 times 3 is 9. 4 times 1 is 4. 9 minus 5 is 4. 4 equals 4. We know our numbers are correct. Always checking your answer to make sure that all of your algebra works, that the answer works, etc. Okay, we have 7D. So notice we've been working in one variable so far. Let's start to work in 2. So the sum of two numbers is 9. Let A equal first number. Let B equal second number. So the sum of these two numbers is 9, so A plus B equals 9. And the difference between these numbers is 31. A minus B equals 31. Sum plus, difference minus. Okay, so let's isolate for a variable. So if I minus B from both sides, A will simply equal 9 minus B. That's a 9. And if I take what A is equal to and I put it in for A in the other equation, we're going to get 9 minus B equals 31. We'll get 9 minus 2B equals 31. We'll subtract 9 from both sides. Minus 2B equals 22. Divide both sides by negative 2. B equals negative 11. Circle your answer. Take that, put it into the equation for A, skip a couple lines. A equals 9 minus negative 11, our B value we just figured out a second ago. Therefore, A equals 9 minus negative 11 is 9 plus 11, which then therefore A equals 20. Circle your answer. Check your answer. So make sure they have a sum of 9. So we have A plus B equals 9, and 20 plus negative 11 equals 9, which is 20 minus 11, which equals the right-hand side 9, and 20 minus 11 is 9. 9 equals 9, check mark. And then the other one, A minus B, the difference equals 31. So we have 20 minus negative 11 equals 31, which is simply 20 plus 11 equals 31. And the left-hand side, 20 plus 11 is 31, and the right-hand side is 31. Therefore, we know we're correct. A is 20, B is negative 11, and then sometimes it's a good idea to answer the question in English. First number equals 9. Excuse me, first number equals A, which is 20, and second number equals B, which is negative 11. Circle your answer. So some teachers will allow you, if you do let statements, just to circle your answer based on A and B equal. Some teachers like you to really make sure that you answer the question by writing a small English sentence, letting you know you completely understand. When you're studying your word problems, it's going to be such a good idea to write these little English sentences. So when you're going back and you're studying it, it's going to be so much quicker that rather than trying to refigure out everything that you did and what the answer was. Okay, now and then problem. 4 years less than triples Mark's age equals 14 years more than double his age. How old is Mark? So we're always going to make the question the let statement. So let M equal Mark's age. So 4 years less than triple Mark's age. So if Mark's age is M, triple his age would be 3M. And 4 years less than that would just be minus 4 is equal to 14 more than double his age. So double his age would be 2M, and 14 more than that would be plus 14. Solving the equation, if I minus 2M from both sides, I'll get M minus 4 equals 14. Add 4 to both sides. M equals 14. Maybe a good idea to answer the question. Mark is 14 year, plus 4, 18. 14 plus 4 is 18. I recorrected it. Mark is 18 years old. Okay, so let's check our answer. So if Mark is 18, triple 18 would be equal to 54, and 4 less than that would be 50. And double his age, 2 times 18 is 36, and 14 more than that is 50. We know that Mark is 18, and we've done it correctly. Okay, now and then problems 8B. So if Nicole were triple her age when she was, if Nicole were triple her age she was 3 years ago, she would be twice her current age. How old is Nicole now? So it's very helpful to, first of all, how old is Nicole now? So let N equal Nicole's age now. Okay, so it's very helpful to make a now and then table. So now and then. So Nicole now is N. Nicole then, so if Nicole were triple her age 3 years ago, then her age would be N minus 3. Easy enough. So now it's telling us an equation. So if Nicole were triple her age she was 3 years ago, so triple her age then. If she's N now, then 3 years ago she will be N minus 3. And triple her age 3 years ago will just be 3 times that. She will be twice her current age now. Okay, so we can distribute. So we're going to get 3n minus 9 equals 2n minus 2n from both sides. We'll get n minus 9 equals 0. Add 9 to both sides. N equals 9. Circle your answer. So you can write out the English sentence. Nicole's age is 9 now, but again, find out it from your teacher. If you declare your let statement properly, then all you have to do is state your variable. If they want you to answer the question, you say Nicole is 9 years old now. So let's check our answer. So it says if Nicole were triple her age she was 3 years ago. So triple 3 years ago. So if she's 9 right now, 3 years ago she would have been 6. So triple her age 3 years ago would be 18, and double her current age is also 18. Therefore, we know it is correct. Nicole is 9 years old right now. Okay, question number 9. Now it says 9A, but there's only one question from 9, whatever. The perimeter of a rectangle. So let's draw a rectangle, and they've said the perimeter is equal to 44 centimeters. So find the length and width if one dimension is 2 centimeters longer than the other. So let's call the width width and the length width plus 2. You could have interchanged those, and you also could have used W minus 2. Long story, feel free to try those different solutions on your own. So what's the formula for the perimeter? Well, the perimeter is just adding up all the sides. So we have W plus 2, and we have 2 of those. So we have another plus W plus 2, working our way around the rectangle, and that is 44. So on the left-hand side, we have 4W. W plus W plus W plus W is 4W, and we have 2 plus 2, which is 4, which equals 44. We can minus 4 from both sides, and we're going to get 4W equals 40. Divide both sides by 4, and W equals 10 centimeters. Circle our answer. Check our answer. Redraw the diagram. Put in a width of 10. 10 plus 2 is 12. Put in the other dimensions, and check your answer. 10 plus 10 plus 12 plus 12 is equal to 44. We know that the width is 10 and the length is 12 centimeters. Awesome. Okay, number 10. So, y equals mx plus b, money in the bank problems. Kira has $2 in the bank and saves 50 cents a day. So, if we have this equation here, then we will start off by declaring our variables. So let's let capital D equal dollars in bank. And then let's say let lowercase d equal number of days. So Kira has $2 in the bank right now, so Kira's equation is D equals 2 plus 0.5 lowercase d. So that is in the equation y equals mx plus b, but it's in the form b plus mx. A lot easier to create the word problems in this form first. Okay, so that's Kira. Now Brian, I'm going to put the equation beside it. Brian's dollars in the bank. Brian has $11 in the bank, and he's spending, so minus $1 every day. So there's going to be our two equations, and now we need to find the intersection and graph and interpret the intersection and describe the domain below and above. So, first of all, let's find the intersection so we can make our equations equal to each other. So 2 plus 0.5d equals 11 minus d. Now 0.5 is just 1/2, so I'm just going to erase 0.5 and replace it with 1/2. I have a 2 on the bottom. To get rid of a 2 on the bottom, I'm going to times both sides by 2. On the left-hand side, we have 2 times 2 is 4. 1/2 times 2 is simply 1d. 11 times 2 is 22. And negative d times 2 is negative 2d. Okay, so if we add 2d to both sides, we will get 4 plus 3d equals 22. Minusing 4 from both sides, 3D equals 18. Dividing both sides by 3, D equals 6. Circle our answer. Take the easier of the two equations. This one's right here. I'm just going to rewrite it and substitute in for lowercase d that we just figured out to find that capital D equals 11 minus 1 times 6 is 6. 11 minus 6 will be 5. Circle your answer. Okay, so I hope that you are using your graph paper using the same number of lines as I am. However, I need to shrink mine up a bit so now I can actually graph the solutions. So, if we take our graph and we mark our axes, let's put D, capital D, on the vertical, dollars in the bank, and lowercase d on the x. So our first equation is 2. So we have a y-intercept of 2. And we're going up 1 over 2. 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 For our equation, D equals 2 plus 1/2. D, remembering 0.5 is just 1/2. And draw a line through it. So that's Kiera's bank account. Oh, was I allowed to draw a line through it? No, technically not. But let's leave it there just for fun. Okay. Now, the other equation. We have a y-intercept of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice I'm up in the way of my graph. So I'm just going to erase what I just did. I'm just going to extend my y-axis going up a bit longer. I'm going to relabel my axis in the middle, D, and put my point back 11. Now we're going down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. There's our intersection. Down 1 over 1, down 1 over 1, down 1 over 1. I'm going to put a line through it again just because we can, but technically these are not continuous functions. We are spending money or depositing money. However, we don't exactly know how we're spending or depositing that money. So technically we could. Okay, so that is the intersection. So the intersection is simply 6, 5. What does that mean? Well, it means in 5 days, Kiera and Brian will both have $6 in the bank. Then it says interpret the intersection, which we just did, and describe the domain in below and above. So below meaning like over here, that means that Kiera has less money in the bank than Brian because every single one of her points is below. And then above, over here, then Kiera has more money in the bank than Brian does. Kiera is saving her money. Brian is spending his money. Therefore, at some point in the future, and specifically in 6 days, they will simply have the same value of $5 in their bank account. So using a word problem, making our let statements, making our equations, solving by substitution, solving for the variable, resubstituting into the easier of the two equations, finding our other variable, describing the intersection, and explaining before and after the intersection. Okay, question number 11. So, one cell phone company charges $2 per gigabyte. So let's let G equal number of gigabytes. Another company charges $20 per month plus $50 per gigabyte. So let's let capital C equal the charge. The charge by your cell phone company. You could write that charge cell company. So how much they're going to charge you each month for using your gigabytes. So one cell phone company charges you simply $1 per gigabyte. The other company charges you $20 plus 50 cents or $0.50 per gigabyte. It's going to be easier using fractions. Okay, so we have our two companies. We have C equals 1G and C equals 20 plus 1/2 G. Because we're wondering what the intersection is, we're going to make them equal to each other. So we can say 1G equals 20 plus 1/2 G. Now notice in the last equation I times both sides by the lowest common denominator. Let's not this time. Let's subtract 1/2 G from both sides. So if we add fractions, 1 minus 1/2 is simply times the top and bottom by 2. The 2's over 1. So we'll simply get 2 over 2 minus 1 over 2 equals 1/2. And on the left-hand side, we simply have 1/2 G equals 20. Now notice we have to times those sides by 2 anyways. 2 times 2. So on the left-hand side, the 2's cancel. We'll get G equals 40. Now I could take the easier equation, C equals 1G, but I'm going to take the harder equation, C equals 20 plus 1 over 2G. I'm going to take 40, substitute in for G. C equals 20 plus 1/2 times 40. C equals 20 plus 1/2 times 40 is 20. Therefore, C equals 40. Notice that's some sort of a coincidence. So let's graph that. So this is exactly the question from earlier in number 6, whereby we've just graphed 2 of the equations, but not the third. So, as seen from question number 6, C equals 1G, our first equation, will just have a slope of 1. And then, if we go up by, let's say, 20s, then our other equation has a y-intercept of 20, so we can mark that. And this time we're up 1 over 2. Notice how useful it is to use graph paper with our gigabyte axis and our cost axis. So this is the intersection. If we use 40 gigabytes of data, it costs $40. You can write an English sentence if you like. If we use 40 gigabytes of data, it costs $40. If we use less than 40 gigabytes, we'll want to choose the company that uses less. C equals 1G. If we use more than 40 gigabytes, again, we're going to want to use the equation that uses less. C equals 20 plus 1/2 G. We are going to be making decisions like this in real life all the time, finding an intersection based on our personal preferences or uses, and deciding based on that information. Okay, 12A, a person has a total of 16 coins in dimes and loonies. So we can let D equal the number of dimes and we can let, so we have dimes and loonies, let L equal the number of loonies. Notice I just used the tick tick. I'm going to redo that in red. So tick tick just means exactly the same word above. Sometimes it's very useful to lower the number of words that you have to write, make it easier to read. Okay, so we've got 16 of those, so D plus L equals 16. Notice in my second let statement I said led L, let L. I've recorrected that in red, let L. So we have 16 total coins, so we have D plus L equals 16. Now the value is 880, so the value of our dimes is going to be the value of a dime, 0.1, times by the number of dimes, plus the value of a loonie, 1, times the number of loonies is equal to 8.80. Okay, so let's solve. So let's isolate for a variable. So let's minus L from both sides and get D equals 16 minus L. And then substitute that into the other equation. So putting brackets around what D is equal to, putting brackets around D in the other equation, and substituting in for D. So we get 0.1 times 16 minus L plus 1L equals 8.80. Distribute 0.1 times 16 is going to be 1.6. 0.1 times negative L will be minus 0.1L. Plus 1L equals 8.80. Let's subtract 1.6 from both sides. And then negative 0.1L plus 1L. That kind of looks funny above. I've kind of written LL. I'm going to put that back in red. Plus 1L is simply 0.9L equals 880 minus 1.6 will be 7.2. We divide both sides by 0.9. We're going to get L equals 8. Circle our answer. Take the other equation, skip a couple lines. D equals 16 minus 8. Our L value that we just figured out. And D equals 8. Circle your answer. Then you'd answer the question. We have 8 dimes and 8 loonies. Feel free to write that English sentence out. Again, ask your teacher if it's okay if you write your let statements properly, then you just have to answer in variable form, or if they want you to write an English sentence. Either way, we're going to check our answer. 8 dimes will be worth 8 times the value of a dime, worth 0.80, 80 cents. And 8 loonies times by the value of a loonie, 1, equals $8. And $8 plus 8 plus 80 cents is $8.80. And we know that we are correct. Okay, let's see another one of those examples. Okay, 12B. So a person has 22 total coins worth of total coins of quarters and dimes. So let Q equal the number of quarters and let, notice I use the ticks, D equal number of dimes. Very helpful to write those tick ticks. It's going to make writing a lot less in the future. Okay, so we have 22 coins, so Q plus D equals 22, and they're worth 520. So our quarters are worth 0.25, the value of a quarter times by the number of quarters, plus the value of a dime times by the number of dimes, just D equals $5.20. So again, we can isolate for a variable. Let's isolate for Q minus D. Q equals 22 minus D. Take that and put it into the other equation, 0.25. Brackets around what Q is equal to, brackets around Q in the other equation. Put that in for that. 22 minus D, excuse me, in black, plus 0.1 D equals 5.2. Distribute. So, excuse me, 0.25 times 22 is going to be 550. So 5.5 minus 0.25 D plus 0.1 D equals 5.2. If we subtract 5.5 from both sides, on the left-hand side, 5.5 minus 5.5 is 0. Negative 0.25 plus 0.1 D is simply negative 0.15. D equals 5.2 minus 5.5 is negative 0.3. And then we can divide both sides by negative 0.15. And we'll get D equals 2. Taking that, putting it back into the other answer, skipping the other equation, skipping a couple lines, 22 minus our D value we just got, Q equals 20. Again, if you want to, write an English sentence, we have 20 quarters. We have 2 dimes. But find out from your teacher again. Okay, let's check our answer. So the value of our quarters will be 20 times the value of a quarter. So 20 times 0.25 will be $5. And then we have 2 times the value of a dime will equal 20 cents. And when we add those up, we get $5.20, our goal. We know that we are correct. Okay, number 13A. A scientist wants to make a 50-liter solution of a 50-liter 40% acid solution. So we have 30% acid solution and 70% acid solution. How many of each? So let's let A equal the number of liters of 30%, and let's let B equal the number of liters of 70%. Notice how I'm using the ticks to drastically reduce the number of things that I need to write. So then we know we have 50 liters, so A plus B must equal 50 because we have 50 total liters. And 0.3 times A, the strength of A, plus 0.7 B, the strength of B, equals 0.4, the final, but we have to times by the total, which is 50. So if we this time isolate for B, let's minus A from both sides, and B will equal 50 minus A. Then we can put brackets around what B is equal to. We can put brackets around B in the other equation, and we can substitute. So we get 0.3A plus 0.7 open bracket, 50 minus A equals 0.4 times 50. 0.4 times 50 is simply 20. Okay, so we can distribute. So we have 0.3A plus 0.7 times 50 will be 35 plus 35 minus 0.7A equals 20. We can minus 35 from both sides, and 0.3A minus 0.7A will equal negative 15. 0.3 minus 0.7 will be negative 0.4A equals negative 15. Divide both sides by negative 0.4. And negative 15 divided by negative 0.4 will simply be A equals 37.5. And B will simply equal 50 minus that, substituting into the other equation the information we just got. Therefore, B equals 12.5. Therefore, we'll have 37.5 liters of the 30% solution and 12.5 liters of the 70% solution to make a total solution of 40% for whatever reason that scientist needs. Okay, 13B. A person spends $17.40 on 12 kilograms of bulk candy at $1.20 per kilogram and $1.80 per kilogram. How much do they spend on each? So we can let A equal the number of kilograms of the $1.20 candy, and we can let B equal the number of kilograms of the $1.80 candy. Notice how I use the tick tick to represent exactly what was above twice. So we're buying 12 kilograms of bulk candy, so A plus B equals 12. And then we're going to have 1.2A, the amount we're going to spend on A, plus 1.8B, the amount we're going to spend on B, and that's going to be equal to $17.4 given in the question. So in the equation on the left, let's isolate for A, so minus B from both sides. A equals 12 minus B. Brackets around what A is equal to. Brackets around A in the other equation. Substitute, so we'll have 1.2 open bracket 12 minus B plus 1.8B equals 17.40. So if we distribute, 1.2 times 12 will be 14.4 minus 1.2b plus 1.8b equals 17.40. If we minus 14.4 from both sides, we're going to get negative 1.2b plus 1.8b will be 0.6b equals 17.4 minus 14.4 will be 3. Divide both sides by 0.6 and we'll get b equals 5. Circle our answer, substitute back into the other equation. A equals 12 minus 5 into our other equation. Therefore, A will equal 7. Feel free to write an English sentence. We are buying 7 kilograms of the $1.20 candy and 5 kilograms of the $1.80 candy. And now let's check our answer and make sure it works. So first of all, 7 plus 5 is equal to 12. And then 7 times 1.2 plus 5 times 1.8 equals, so on the calculator, 7 times 1.2 plus 5 times 1.8 is equal to the 17.4 that we needed in the beginning. Okay, we have 14A. Investments in mixtures. So Mason invests a total of $2,800 in a 12% bond and an 8% bond, earning $288. How much did he invest in each? Okay, so let's let A equal the amount in the 12% bond, and let's let B equal the amount in the 8% bond. So we invested a total of $2,800, so A plus B equals $2,800. Then the amount we're going to make off the investment in bond A is 0.12A. The amount we're going to make off the investment is B is plus 0.08B equals the amount that we're going to make total, $288. Okay, so in the equation on the left, we can isolate for a variable. Let's isolate for A, so minus B from both sides, and A equals 2,800 minus B. Brackets around what A is equal to, brackets around A and the other equation, and we can substitute. 0.12, excuse me, 0.12, 2800 minus B plus 0.08 B equals 288. If we distribute, 0.12 times 2800 is 336 minus 0.12 B plus 0.08 B equals 288. If we minus 336 from both sides, on the left-hand side, 336 minus 336 is 0. That's gone. Negative 0.12 plus 0.08 is negative 0.04b equals 288 minus 336 is negative 48. And if we divide both sides by negative 0.04, we're going to get b equals 1200. Circle your answer. Substituting the other equation, A equals 2800 minus 1200. Therefore, A equals 1600. Circle your answer. Feel free to write an English sentence. We are investing $1,600 in 12%, and we're investing $1,200 in the 8% bond. Let's check our answer. 1,600 plus 1,200 equals 2,800, check mark. 1,600 times 0.12 plus 1,200 times 0.08, the equals the value of the bond times the percentage plus the value of the bond times the percentage, better equal $288. If those both last checking our answers are good. Okay, 14b. If you mix 6% alcohol with 8% alcohol, how much of each would you have to mix to have a total of 10 liters at 7.4% alcohol? So let A equal amount of 6% and let B equal the amount of 8%. So we know that we need a total of 10, so A plus B equals 10. And then our percentages, so 0.06A plus 0.08B equals 0.074 times 10. So that's the idiosyncrasy, and we actually have to multiply the right-hand side like we did with mixtures of a scientist earlier in question 13a, where sometimes the word problem's right-hand side is just given. So be very careful with that multiplication on the right-hand side. Okay, so we can isolate for a variable. So if we subtract b from both sides, we'll get a equals 10 minus b. Put brackets around what a is equal to. Put brackets around a in the other equation. We can distribute 0.06 times 10 minus b plus 0.08 b equals 0.074 times 10. Okay, so we can distribute. So 0.6 times 10, 0.06 times 10 will be 0.6 minus 0.06 b distributing plus 0.08 b equals 0.74, minusing 0.6 from both sides. On the left-hand side, 0.6 minus 0.6 is gone. Negative 0.06 plus 0.08 will be 0.02b equals 0.74 minus 0.6 will be 0.14. Divide both sides by 0.02. And b will therefore equal 7. Circle your answer. Put it in the other equation. A equals 10 minus 7. A equals 3. Circle your answer. We will need 3 liters of the 7% or the 6% alcohol, and we'll need 7 liters of the 8% alcohol to have a total. Let's check. 3 plus 7 equals 10. Good. And then the percents have to work out as well. So 0.06 times 3 plus 0.08 times 7 must equal 0.074 times 10. So on the left-hand side, if we type into our calculator, we're going to get 0.06 times 3 plus 0.08 times 7. The left-hand side is 0.74, and the right-hand side is also 0.74. We know we've done it correctly. Okay, number 15. Adult tickets for a soccer game are $12 and children's tickets are $6. If the soccer game has 100 attendees and does $966 in revenue, how many of each adult ticket and children tickets are sold? So let's let A equal the number of adult tickets, and let's let B equal the number of child tickets. So we have a total of 100 tickets, so A plus B equals 100. And then we have a total of $966 in revenue. So 12, the value of an adult ticket, times by the number of adult tickets, plus 6, the value of a child ticket, times by the number of child tickets, B, equals $966. Notice you could have used a variable like C for child tickets, but all the same, actually it probably would have been a better idea. Okay, so let's isolate for a variable, minusing B from both sides. A therefore equals 100 minus B. Brackets around what A is equal to, brackets around A in the other equation. Substitute 12, open bracket, 100 minus B plus 6B equals 966. 12 times 100 is 1200. Minus 12B plus 6B equals 966. If we minus 1200 from both sides, on the left-hand side, we're going to have negative 12B plus 6B, which is minus 6B. On the right-hand side, we're going to have 966 minus 1200, which gives us negative 234. And if we divide both sides by negative 6, we'll get B equals 39. Circle your answer. A then therefore equals 100 minus 39. Therefore A equals 61. Circle your answer. Check our answer. 39 plus 61 equals 100. Absolutely. Now the value. So we have 61 adult tickets. So 61 times by the value of a ticket, plus we have 39 children tickets times by the value of a children's ticket, and that better be $966. So let's check that on the calculator. 61 times 12 plus 36 times 6 is equal to, 39 times 6. I'm going to erase that and put that in red. 39, excuse me. I didn't get 966, I got 948. Just a great check. So let's try that again. 61 times 12 plus 39 times 6 is equal to 966. Check mark. Feel free to answer the question. We have 61 adult tickets and 39 child tickets going to the soccer game. Okay, we have 16A. So a plane averages 115 kilometers per hour. So I'm going to draw a line That's going to represent 115 kilometers, and this took 1 hour. What a sharp. With a tailwind, so we've got a tailwind. And then, in one direction, and 85 kilometers per hour on the return trip into the wind. So then we return and only go 85 kilometers per 1 hour into the wind, so against the wind this time. Find the speed of the plane in still air. So let's declare a variable. So let v equal speed of plane still air. So we don't use s because it looks like a 5. V is for velocity, but v equals speed. So now when we're going with the wind, our speed is going to be the velocity of our plane in still air plus the wind speed. So, excuse me, I'm going to have to let W equal wind speed. So V plus W will equal 115. And then the equation off to the right, when we're going against the wind, our speed will be the speed of the plane in still air minus W equals our speed 85. So in the equation on the left, we can minus W from both sides. Therefore, V equals 115 minus W. Brackets around V in the equation, brackets around V in the other equation. Substitute 115 minus W equals 85. Those brackets are unnecessary. I can scribble them out. We can subtract 115 from both sides. So on the left-hand side, we're going to get minus W, which is just minus 2W. On the right-hand side, we're going to get 85 minus 115, which is negative 30. We're going to divide both sides by negative 2 and get a wind speed of 15. Put that back into the other equation. V equals 115 minus 15, and V equals 100. The velocity of our plane in still air is 100 kilometers per hour. Don't forget your units. Kilometers per hour. Kilometers per hour. Okay, a boat took 6 hours to sail downwind with the wind. Okay, so let's start by designing our diagram. So we travel a certain distance. We don't know. This took 6 hours to travel the distance. And this time we're going with the wind, and we know that the wind speed is 12. So the return trip, the same distance, this time took 10 hours to go the same distance, but this time we're going against the wind of 12. So let's declare our variables. So let V equal boat speed still air, meaning no wind, still air. Good. So now let D equal distance traveled. Okay, so we have our equations for speed. Speed equals distance over time. Whoops. Speed equals distance over time. Again, off to the right, speed equals distance over time. Now, when we're going with the wind, our speed will be the velocity of the boat plus 12 equals D over 6. Off to the right, our speed will be going against the wind. So V minus the speed of the wind equals the distance over 10. Now, we don't like these fractions, so we're going to clean these fractions up. So let's multiply both sides by 6. So if we distribute backwards, we're going to get 6v plus 72 equals d. And the equation on the right, we're going to times both sides by 10 and distribute backwards. And we're going to get 10v minus 120 equals d. Now if 6v plus 72 equals d and 10v minus 120 equals d, then we can make these two equations equal to each other. So 6v plus 72 equals 10v minus 120. We can subtract 6v from both sides. Therefore, 72 will equal 4v minus 120. We can add 120 to both sides and mirror it. 4v equals 192. Divide both sides by 4, and v equals 192 divided by 4 will be 48. Therefore, we can put that back into one of the simpler equations. How about the one on the right? V minus 12 equals d over 10. Taking the v value of 48 that we just got and substituting it, 48 minus 12 equals d over 10. 48 minus 12, 48 minus 12 will be 36. And times both sides by 10. And d equals 360. So, the velocity of the boat in still water, or still air, excuse me, is 48. And the distance that we're traveling is 360. Okay, we forgot to check our answer. Let me shrink up my work a tiny bit. And then let's take the equation. So speed equals distance over time. So if our speed is v plus 12 and our velocity that we just figured out is 48 from above, 48 plus 12 will be 60. Our distance is 360 over 6, check mark. The equation on the right, v minus 12, if our v is 48, v minus 12 will be 36, equals the distance, 360, over the time, 10, check mark. We know we're absolutely correct. Okay, 16C. A boat took 3 hours to travel 24 kilometers with a current of 5. Oh, with a current and 5 to return. So a boat took 3 hours. So let's draw a line representing 3 hours to go 24 kilometers with the current. So let's put C there. And 5 hours to return. So to return the same distance, 5 hours, 24 kilometers. Now it hasn't told us the current has gone away, so we're assuming it's still there, going against the current. So what is the speed of the boat in still water? So let V equal boat speed still water. Let C equal current speed. Okay, so we know that S equals d over t. Again, S equals d over t. So when we're going with the current, our speed will be the velocity of the boat in still water plus the current equals the distance, 24 over 3. And then on the equation on the right, we're going against the current, so it's going to be v, the velocity of the boat, minus the speed of the current equals the distance, 24 over the time, 5. So these equations are going to clean up nicely. So we have v plus c equals 8, and we have v minus c equals 24 divided by 5 is 4.8. So isolating for a variable, let's subtract c from both sides. V equals 8 minus c. Substituting that into the other equation, brackets around what v is equal to, brackets around v in the other equation, substitute. So we're going to get 8 minus c equals 4.8. If we minus 8 from both sides, we'll get 4.8 minus 8. Minus c is negative 2c equals negative 3.2. Divide both sides by negative 2. C equals 1.6. Take that, put it in the equation off to the left. V equals 8 minus 1.6. 8 minus 1.6 will be 6.4 kilometers per hour. And on the current, kilometers per hour. So the question was asking for the speed of the boat in still water, so we gave them that as v. We could now again check our answer like we have been, but I've done that enough times, so I will let you do that on your own. Okay, number 17. A truck travels 500 kilometers in the same time a car travels 400 kilometers. Okay, so let's start off with the truck represented by T and the car represented by C. So if we draw a line, the truck goes 500 kilometers and the car goes 400 kilometers. Now it said they took the same time, so how long did it take? We don't know. Let T equal the time. Let T equal time. Now the truck travels 10 kilometers faster than the car. So let's say the car goes V. Let V equal car's speed. Therefore, the truck will simply be going V plus 10. Okay, so let's start off with S equals D over T. Again, S equals D over T. And let's substitute. So the equation on the right is going to be a little bit simpler, so let's start there. V equals 400 over T. The equation on the left, the speed is V plus 10. So we're going to take V plus 10 and substitute it. Then our distance is 500, and again it's over T. So this time we have V equaling 400 over T. We can put that in for V in the equation on the left. So we can say 400 over T plus 10 equals 500 over T. Now we have a T on the bottom. We simply just want to times both sides by the thing on the bottom, and that will cancel. So we get 400 plus 10T equals 500 minus 400 from both sides. 10T equals 100. Divide both sides by 10. T equals 10. So we were given kilometers per hour, so this is going to be time in hours. And then let's find the speed of the car. So V equals 400 divided by 10. V equals 40 kilometers per hour. Circle your answer. Again, you could go back and check your answer by taking these values and resubstituting back into the speed equals distance over time equations and make sure that they work. Okay, number 18. A helicopter drops a parachute of medical supplies from a height of 800 meters to a building 100 meters tall and falls at 10 meters per second. When will it reach the building? So let's let H equal height in meters, and let's let T equal time in seconds. So the helicopter is going to have an equation of height equals its current height minus the falling height, 10 meters per second, times by the number of seconds. Now the building's equation is just H equals 100 the whole time. So if H equals 100, we can substitute that into the equation on the left. 100 equals 800 minus 10T. We can subtract 800 from both sides. and we'll get negative 700 equals negative 10t. Divide both sides by negative 10, and t equals 70 seconds. So, when will it reach the building? That is the time that it will reach the building. If it's falling from 800 at 10 per second, it's going to be a table of values of time and height. At 0 seconds, we're at 800. 1 second later, we're at 10 less than that, at 790. At 2 seconds, we're at 780. And all the way down until we're at 70 seconds, we will hit the building of 100 meters. Okay, 19A, a 2-point question. Typically, the cost of making something includes a cost, unit cost plus a fixed cost. Okay, one day of the week, a pizza store makes 100 pizzas and costs $550. Let's let P equal the number of pizzas, and let's let C equal the cost of pizzas. Okay, so we have two variables. So let's go for P comma C, because cost depends on the number of pizzas and Y depends on X. So our 2 points are, if we make 100 pizzas, it's 550. And if we make 200 pizzas, it costs 1,050. So we're going to first find our slope. M equals y2 minus y1 over x2 minus x1. 1,050 minus 550 over 200 minus 100. M equals 500 over 100. M equals 5. So then, taking that equation and putting it into y equals mx plus b, we have y equals mx plus b. Changing our variables, we have c equals mp plus b. Taking our m value that we just figured out, c equals 5p plus b. Plus b. Then taking our simpler point, 100 comma 550, and substituting it in for x and y. So I'm going to identify p and c from above and substitute. So we have 550 equals 5 times 100 plus b. Therefore, 550 equals 500 plus b. If we minus 500 from both sides, we'll get b equals 50. And our final equation will be c equals 5p plus 50. So, find the cost to rent the store for the day. Well, if we have a charge of $5 per pizza, then our cost of renting the store will be $50. So rent store equals $50. So that is a classic 2-point question. I left it at the end because it's just a little bit different than all the other questions where you just go for the equation right away. You have to identify that they're giving us 2 points. You have to find the slope, find the b value and find the equation, and then interpret the slope and the y-intercept, whereby we're some sort of a pizza company and our cost equation is $5 times by the number of pizzas plus some fixed costs of $50 per month to rent the store.